All right. Have a good day. Assalamualaikum. Welcome back, to our class sessions. So today I'm going to talk about the module 12 regarding network troubleshooting. Okay. Okay, module objective: troubleshoot enterprise network. So first topic, network documentation. First topic, network documentation. So objective of this topic is to explain how network documentation is developed and used to troubleshoot network issues. And second, we have troubleshooting process. So in troubleshooting process, you will learn to compare troubleshooting methods that use a systematic, which is layered approach. And then third things, troubleshooting tools. So in here, you will describe different networks. So describe different network troubleshooting tools. So we use a tool to do a troubleshoot. And next, we have a symptom and causes of network problems. In here, all right, in this title, you will be learn how to determine the symptoms and causes of network problems using a layered model. And finally, troubleshooting IP connectivity. So in here, we learn how to troubleshoot a network using a layered model, or here they call layered approach, similar things. So that's regarding this module. Okay. Network documentation. So what is basically means by this? What is this documentation? Or network documentations. So now look for documentation overview. First of all, accurate and complete network documentation is required to effectively monitor and troubleshoot networks. The common network documentation include the following item. First, physical and logical network topology. Second, network device documentation, which will record all pertinent device informations. And then another things, network performance baseline documentations. Okay, so you must have a documentations. Very important, the report. So that's mean, or you can use documentation, word, or you can say report, so on. So the detail of that. So all network documentation should be kept in a single location and backup. And we do backup documentation should be maintained and kept in a separate locations. This one for security purposes. That's why we keep in separate locations. All right. So network topology diagram. So there are two types of network topology diagram, if you can see here, physical and also logical type. Okay, so this one more on, you can see the physically, connected and so on. But this one logical topology, because of VPN, try to group all the user. So that's why we say that this is logical topology. So network device documentation. This is the how it looks. The documentation which related to network device. So network device documentation should contain accurate, up-to-date records of network and also software. Documentation should include all pertinent information about the network devices. Okay, maybe the small company, this work is like a tedious work to do that. Okay, but big company, normally we have this kind of documentations. Yeah, similar to topology whatsoever. All right. So this is, I can say, is a standard, yeah, standard rules. Because we are computer scientists, for example, sometimes we normally it's similar like when we do a programs and we ignoring the what we call this development process, the design, the report, and so on. We don't bother that. We don't draw properly the flow chart and so on. Similar to these things. Okay, so you must have a documentations. So by the time we pass the work, not necessarily just for maintenance. Sometimes we want to pass our job, our duty to a new staff. So we need to have this kind of documentation. Let them read everything. That is difficult to explain to them, yeah? Not just for the sake of, the report only, but report is very useful for maintenance, for new staff, and everything. In future, if you want to do a scalable, you want to extend and so on, we need to have this kind of documentations. Yeah? All right. So establish a network baseline. A network baseline is used to establish normal network performance to determine the personality of a network under normal conditions. Establish a network performance baseline, yeah, requires collecting performance data from the ports and devices that are essential to network operation. The base data is provide insight into whether the current network design can meet business requirements. Second, can reveal area of congestion or area in the network that are underutilized. Step 1, determine what type of data to collect. When conducting the initial baseline, start by selecting a few variables that represent the defined policies. If too many data points are selected, the amount of data can be overwhelming, making analysis of collected data become difficult. So start out simple and fine-tune along the way. Some good starting variables are interface utilization and CPU utilization. Right? So first step 1, determine what type of data to collect. Step 2, identify devices and ports of interest, or POI. A logical network topology can be useful in identifying key devices and port to monitor. As shown in the sample topology, the devices and ports of interest include PC1, admin terminal, 2 servers, router interfaces, key port on switches. All right. This is the topology. Yeah. Sample topology. Okay. Step 3, determine the baseline duration. When capturing data for analysis, so the period specified should be at minimum 7 days long. Can be more than this. So at a minimum. Last no more than 6 weeks. 6 weeks. Unless specified long-term trend need to be measured. Generally, 2 to 4 week baseline is adequate. Conduct an annual analysis of the entire network or baseline different section of the network on a rotating basis. Analysis must be conducted regularly to understand how the network is affected by growth and other changes. Right? Data measurement. The table lists the table, if you can see here down the following table, here lists some of the most common Cisco iOS command used for data collection. Okay, we have show version, show IP, all the way you can see the keyword is show. Yeah, when you using a packet address, so you can type this also show or sh. So this is the way how we collect all the data. Okay, all right. So you can have a look at each of that. Yeah. So show version, for example, display uptime, version of information for device software and hardware, and the rest of this. Okay, all right. So next, troubleshooting process. Once you have documentation, and now we look for troubleshooting process. So general troubleshooting procedure. Troubleshooting can be time consuming because networks differ. Yeah. Problem differ and troubleshooting experience varies. Using a structured troubleshooting method will shorten overall troubleshooting time. There are several troubleshooting processes that can be used to solve a problem. The figure display here the logic flow chart of a simplified three-stage troubleshooting process. Three-stage. Okay. Okay. 7-step troubleshooting process. The figure displays a more detailed 7-step troubleshooting process. One, define the problem. Okay. Verify that there is a problem, then properly define what the problem is. Gather information. Target, for example, hosts, devices are identified, access and information gathered. Analyze information like identify possible causes using network documentation, network baseline, knowledge bases, and peers. Eliminate possible causes. Progressively eliminate possible causes to eventually identify the most probably cause. Yeah. Propose hypothesis. When the most probable cause has been identified, a solution must be formulated. Yeah, that's a proposed hypothesis. Test hypothesis. Okay. Assess the urgency of the problem, create a rollback plan, implement the solution, and verify outcome. Then next, solve the problem. Okay, when solved, inform all involved and document that cause and solution to help solve future problem. All right. This one you can see. Where is this? Okay, start from define the problem. What is it? Next here, and then analyze. After analyze, eliminate. After eliminate, propose. Yeah, we do propose, and then test, and then solve. Okay. Question and users. So the table below provides questioning guideline and sample open-ended end user questions. Ask pertinent questions. Guideline. Example open-ended end user questions. What does not work? What does not work? What exactly is the problem? What are you trying to accomplish? Determine the scope of the problem. Determine the scope of the problem. Who does this issue affect? Is it just you or others? What device in this happening on? Next, determine when the problem occurs. When exactly does the problem occur? When was the problem first noticed? Were there any error messages displayed? Okay. Determine if the problem is constant or intermittent. can you reproduce the problem? Can you send me a screenshot or video of the problem? Determine if anything has changed. What has changed since the last time I did work? Okay, use question to eliminate or discover possible problem. What works? What does not work? Okay. So common Cisco iOS command used to gather network problem symptom. First, we use this. Okay, using Cisco iOS command. We have ping, PING. So what's the parameter? Actually, host and also IP address. So ping actually what it do, yeah. So it sends an echo request packet to an address, then wait for a reply. Yeah, trace route, and then this is the trace route, the parameter where, and then this identify the path a packet takes through the network, the path. Yeah, this one more on path. Okay, telnet, either host or using IP address to telnet, you should put in here. Yeah, it means like ping, IP telnet similar. So means connect an IP address using the telnet applications. Okay, and then SSH for security. SSH connects, yeah, to an IP address using SSH. And then the rest, like these two, is more on get the info, show IP interface, show IPv6 interface, and then show IP route v6. Okay, all right. So debug, last one, debug display a list of options for handling or disabling debugging event. Troubleshooting with layered model. The OSI and TCP/IP models can be applied to isolate network problem when troubleshooting. The figure shows some common devices and the OSI layers that must be examined during the troubleshooting process for that devices. Okay, all right. Structured troubleshooting method. Different troubleshooting approaches that can be used include the following item here. So troubleshooting approach, first bottom up. Bottom up. Good approach to use when the problem is suspected to be a physical one. Top down, use this approach for simpler problem or when you think the problem is with a piece of network, piece of software. Top down. Divide and conquer, start at a middle, like layer 3, and test in both directions from that layer. And then next, follow the path. Use to discover the actual traffic path from source to destination to reduce the scope of troubleshooting. Substitution. You physically swap, okay, a suspected problematic device with a known working one. Yeah. Okay. Comparison, attempt to resolve the problem by comparing a non-operational element with the working one. Educated guesses. Success of this method varies based on your troubleshooting experience and facilities. Guideline for selecting a troubleshooting method. To quickly resolve network problem, take the time to select the most Yeah. Select the most effective network troubleshooting method. The figure illustrates, yeah, which method can be used when a certain type of problem is discovered. Troubleshooting is a skill that is developed by doing. Every network problem you identify and solve gets added to your skill set. Troubleshooting process.